We've had an absolutely fantastic Ostmine conference. Over 1,200 delegates. We've had a world-class lineup of speakers and exhibitors who were part of this event. And I look forward to seeing you in 2021 in Perth.
Hello, my name is Erik Isokangas. I'm one of the Program Directors at Mining 3, based here in Brisbane, Australia. Today I would like to present a short introduction to our research organisation and the work we are doing around modelling the value of future technologies and the changes they could make for the mining industry. Mining 3 is a not-for-profit research organisation fully funded by our members and industry. We are one of the largest global mining research centres with in-house research capabilities, bringing industry and researchers together to work on transforming mining. Our research is guided by our members, and at present we have 5 mining companies and 4 equipment and energy suppliers. We are also closely aligned with CSIRO, University of Queensland, Queensland University of Technology and Curtin University. Our research is structured around 3 pillars. The first pillar is called in-place mining. In-place mining is about rethinking the mining process. It's about margin over volume, moving toward a smaller footprint and reducing surface infrastructure, minimising material movement through selective mining, in-mine extraction and in-situ recovery. The second pillar works towards lean minerals production, developing sensors, analytics and systems that optimise the mining value chain, providing the right information at the right time and right place, making intelligent decisions and integrating automation into the mining process. Finally, our third strategic pillar considers sustainability. And while sustainability is a huge area for development, we focus on the technologies that enable sustainability, such as low or zero waste, reducing energy consumption and improving safety. We also develop systems to model the value chain, to understand the benefits and impact of new technologies and innovation in the mining process. Our mission is to develop and push technologies to transform the mining industry, improving productivity, sustainability and safety. Through this research and development process, we need to bring the industry along by demonstrating the concepts, but also showing the value of the changes proposed. When valuing new technologies and changes to the way that we mine, we need to keep our eye on the bigger picture. For example, on our roadmap, one of our visions looks towards the zero carbon mine. To some, reducing carbon emissions might mean replacing diesel with electric or green hydrogen systems. However, it's not just about the diesel consumption, but the whole value chain of generation, delivery, storage, and application of green energy. As I'll show later, even changing from diesel trucks to battery electric opens up new opportunities to redesign the mine and create more value than just replacing trucks. To identify the value from these technological solutions in a comprehensive and holistic manner, Mining 3 has developed a multi-component, multi-scenario tool for the mining industry, which we call V3. V3 is a collection of plug-in models that integrate, develop, depending on the solution being studied. Looking at it a bit more closely, the framework builds the high-level metrics from the ground up. We use a discrete event model to simulate the mining operation, which feeds productivity and utilisation data into a value driver tree. The value tree allows us to build in the cost data and configure various scenarios to compare against the base case, and then conduct sensitivity and attribution analysis. This particular graphic relates to our haulage model, but equally we have developed value driver trees for underground operations, rock breakage and cutting, energy and power, and others. I would now like to talk about a few cases where we have used value models. Coming back to the vision of the zero carbon mine, when you're thinking about what mines in the future will look like, sometimes you need to start with a clean slate and look at the mining operation holistically. Mining 3's efficient haulage project has been looking at haulage and what it might look like if trucks of the future use different combinations of energy sources, such as hydrogen and batteries. Coupled with a level of autonomy and a realistic perspective of the emerging technical constraints, trucks can be designed quite differently. Whilst historically mining has moved towards bigger and bigger trucks, there's a lot of efficiencies that can be gained by going smaller. Not only are there lower energy and maintenance costs, we can potentially redesign the future pit for narrow and steeper ramps. Smaller haulers also allow us to improve selectivity, thus reducing dilution of the ore. Recently, I've been exploring a novel transportation system based on small, let's say 15 to 65 tonne capacity, autonomous electric haulers that are powered and recharged via a wireless inductive charging system that's charging the haulers while they're travelling on the haul roads. Wireless power systems are already available in other industries such as public transport and marine applications, with power transfers up to 2 megawatts and efficiencies close to 90%. And being electrical, it's a technology that can be easily scaled up. In essence, a fleet of autonomous haulers are inductively charged along the haul route, minimising the weight of the hauler's batteries. Another potential advantage of going smaller is that these haulers could be fitted with sensors to measure the bulk material properties of their loads, such as grade, ash or moisture. Thus, decisions about the destination of the load can be made with greater confidence. Effectively, these small haulers could become a sorting system, being directed to the appropriate destination based on the quality of the product in the payload. This is a lean production system. Using our value modelling and simulation system, we studied this concept technology in an open pit operation. The application was at a high-grade, low-volume satellite pit at a gold mine. There are many such small resources like this, many of which wouldn't be mined today as they're generally uneconomic with the current mining equipment. Looking solely at the cost savings, the results indicated that our fleet of small induction-powered haulers would be about 25% lower in cost to operate. These savings came from a reduction in maintenance, energy and labour costs. But as we're only using a mobile crusher and additional electrical infrastructure, capital costs would likely increase. But reduced operating cost is only part of the value proposition. Considering the same pit boundary and resource body, we developed a new pit design based on steeper, more narrow ramps for our smaller electric haulers, as shown in red on the left. As it turns out, the resource extended below RL30, the limit to which the 777s were able to mine within the pit limits. Assuming geotechnical factors allow, this new design opens up the pit for extracting minerals below RL30. The analysis indicated a 23% increase in resource utilisation. Using the smaller haulers would yield an additional $2.5 million in value out of the resource, and that's after taking into consideration the additional cost of moving the extra waste. The next case study considers the introduction of new mechanical cutting technology into an underground mining operation. Conventional drilling and blasting in underground mines involves a sequence of steps as shown here in the top half of the diagram. Replacing this process with the new mechanical cutting technology dramatically reduces the number of steps, but also creates new downstream benefits. A value tree allows us to identify how the features of the new technology can impact on the value of the system to the mine. In the interest of time, I won't go into the details, but we also need to consider and recognise the trade-offs or negative impacts as well, as highlighted in red here. From this value driver tree, we established the value model in V3, which also included a discrete event simulation model. Discrete event simulation allows us to model complex processes, identifying bottlenecks and gaining a better insight into the relationships and sensitivities between the utilisation of equipment in the operation. Like all of our value modelling projects, through this work we were able to also model the impact of using the technology on existing operations. For example, in this case, if drilling and blasting continued and the new technology was introduced in parallel, much of the benefits of the mechanical cutting system were lost due to the regular evacuation of the mine for blasting. The two processes, drill and blast and mechanical cutting, also relied on some common steps and resources, such as ground support, which could become a bottleneck at times and needed to be carefully managed. If there are 2 points I'd like you to take away, is that modelling the value of any change to a mining operation based on a new technology or a way of thinking really needs to take a more holistic approach, considering the effects both upstream and downstream. And Mining 3 has developed and continues to develop a value modelling approach that can be considered for a wide range of these operations. Thank you very much for your time. If you would like to learn more, please visit our virtual booth at this conference.
We've had an absolutely fantastic Ostmine conference. Over 1,200 delegates. We've had a world-class lineup of speakers and exhibitors who were part of this event. And I look forward to seeing you in 2021 in Perth.